Gustav is a land management and grassland science specialist. He is the founding member of Sakela Impilo Services. And Gustav, my research tells me that in English this translates as sustain life and livelihoods. Gustav has more than 15 years of experience in sustainable land management across the mining, forestry, wildlife, and agricultural sectors. His expertise includes grassland rehabilitation, invasive plant management, grazing systems, erosion control, and ecological restoration, with a strong focus on practical, science-based solutions for managing degraded landscapes. Gustav will take a deeper look at the root causes for invasive plant species spread and introduce us to integrated management approaches. Thank you, Gustav. You're welcome to share your screen.
Okay, cool. So as Kristen already said, I'll be focusing more on the monitoring component as a tool for enabling us to address some of the root causes of alien invasive. Not just alien invasive, but the indigenous invaders, the bush encroachers. So in my opinion, in alien invasive control, we've been far too reactive. All those methods of integrated control are great, albeit chemical, biological, cultural, physical, but it's after the events already happened, and we don't really understand why in these natural systems do we create a niche or like a stronghold for these AIS and the indigenous invaders to encroach our savanna or grasslands and etc. So it makes us kind of feel out of control in managing the situation, and it's a bit of a reactive focus instead of focusing on the preactive mindset. So proactive mindset is where we use our monitoring data, our trends in our management systems to anticipate potential challenges, plan ahead, and empower to create. So one of the two tools that we can use is monitoring and evaluation. And monitoring is focused mainly on what is happening currently within your system. It relies on us collecting data, tracking changes, in other words, looking at trends and observing patterns. And then evaluation, what does this actually mean and why does it matter? So we look at various tools that we can use to help us analyze our data. We assess the environmental, social, economic, different aspects and impacts. And then we use that to guide our decision making within the framework of adaptive management. So if we look at alien invasion, let's ask ourselves a question. Despite having spent billions of rands on AIS, in some circumstances, the problem is actually worse than it was pre-intervention. So what could be the possible reasons for that? So one of the things that I think it's complex, and it's there's many different species. So now instead of, and each species has its unique approved and registered herbicide, and then now you have to apply a whole range of, and then also I think one of the questions which was asked earlier, why do we get resistance to herbicides? So a lot of the times you use the same herbicides are classified according to the mode of mechanism of work, right? And we use the same group over and over, and we don't use it according to the label, to the concentration. We don't calibrate our equipment, and this all results in resistance. Just one of the sites as an example. This has, according to NEMBA, so in South Africa, there's two, it's NEMBA and CORA. So NEMBA being more for your natural and CORA being for your conservation areas. In this site, we had about 20 alien invasive listed species, to include non-listed species like in blackjacks, khaki boss, all of those which are still alien, they're less invasive and they're also not registered. Then I think we also are planning. It's also reactive and also inferior. A lot of times these programs are extremely costly, and then we end up ignoring certain phases, whether it be the follow-up, maintenance, or monitoring components, instead of and then also a lot of times we do great work, but our neighbor might not, or the communal area adjacent might not. So in that case, this AIS can actually proliferate way more than what it was pre-intervention. So we need this landscape level approach. And then, as discussed, so the root causes, if I can use a simple example using a medical, if I get a headache every day, instead of drinking Panado, aspirin, or whatever it might be every single day, we find out, why do I get the headache? Is it because I don't drink my 8 glasses of water a day, or I don't eat correctly? Other case might be uh, you might have high blood pressure because you're overweight, cholesterol, but you don't, instead of now taking pills, which is only hiding the symptoms of the problem and not addressing the root cause, which in my case might be overweight or not eating correctly. So that's the root cause. So you need to address both simultaneously. The symptoms through as various speakers have spoken already, through biological, chemical, physical, cultural controls, and integrate them, but then also address the root cause um, of the problem. And then in some cases, a lot of people have landowners have said, adopt a wait and see attitude. They said, no, don't worry, they'll find a biological control that will sort all of this out and will cost us nothing. And then that, as Dr. Llewellyn explained, if you leave it too late, you're creating a massive problem. And it's just one of the examples of biological controls. Um, then also a lot of interventions start really well, cover areas, but then don't follow up, don't maintain, don't monitor. And we need all these different phases in our control. What we also see with AI is people choose the densest area where they can cover the smallest area, but visually it looks great and it makes them feel great. Also, from a community perspective, it employs lots of people. But from an ecological perspective, it's not better to first prioritize the areas that are still relatively intact, that have low densities, where the ecosystem services and functioning, unless it's required by law, like we discussed, that will obviously override this. But um, if it's not, then let's rather focus where we get value for our money. In other words, rand for my buck. And then also considering legislation, rare habitats like wetlands, riparian zones, all of that, and then looking at certain site-specific logistics. So in other words, like in this picture, people would say, oh, this is a prime area to start our alien invasive. Is it really? It's already messed up severely. I'm not saying we shouldn't control them if it's legally required. In this case, in South Africa, it is. Then you unfortunately have to in all areas and at all densities. But if it's not, focus on the light density areas first. And then also a lot of times we clear and do great work, then we don't stabilize the soil. There's no basal cover, no canopy cover, and especially with climate change, with severe rainfalls and intense rainfall. Now you've got these very disturbed areas, conditions under which alien invasives thrive and outcompete and native vegetation. So erosion control, stabilizing these areas is critical to make sure we don't create another niche where these species can flourish. So, what is monitoring and why is it important? Why should we even look at the monitoring component? Um, in our management systems. So it's basically just measuring over time, repeatedly, because we want to look at trends. The methods, yes, some methods are better than others, but I think it's more important that we stick to one method so that we can see how the trend over time and through the principle of adaptive management, learning from our mistakes and improving, putting through continuous improvement, putting things in place. So I've just had simplify this. If you only look at two aspects, there's water, there's air quality, there's wildlife management. It also needs to be considered in your monitoring programs, but I just looked at two aspects. Soil, we look at the chemical. So is there some allelopathy in the soil? Or, and we're also looking at soil pH, the macro elements, nitrogen, phosphorus, potassium, um, carbon being a critical one, far too often ignored. Um, Biological, looking at nematodes, bacteria, fungi. I believe many of our answers lie in the things unseen, like we've seen with biological things, things unseen to the naked eyes. Many of our answers, and if we move to a ecosystem approach and a soil food web approach, we can definitely gain great grounds on these AIPs and indigenous invaders. And physical, we look at compaction, the soil texture, the amount of sand, salt, and clay, and understanding why do certain species thrive, and how can we manage use that, and then also looking at vegetation tools we can use there, species composition along with carrying capacity. Are we overstocked? Do we have the right mix of species? We'll go in a little bit more detail that later. And then structure, what's our ratio? This is with bush encroachment and indigenous invaders. What's our ratio of trees to grasses, or trees and shrubs to grasses and forbs? What is our ratio of these things, and how do we maintain certain felt conditions so that we don't create those imbalances in which these species proliferate and multiply? And then biomass, it's just an indicator of volume, whether it be grass or browse. I think the browse layer has also been ignored for far too long. And then cover from erosion perspective. So the focus here being on we want functional systems that add value to communities, to landowners, to tourists, whatever the land use might be. And we want to look at soil and vegetation health, optimizing that so we don't create these gaps in the ecosystem where the invasive plants can flourish, can outcompete through competitive exclusion, allelopathy, whatever it might be, on native species, with a focus being on what's the value that we can derive from improved water quality. For example, stopping the eutrophication in our dams by fixing our sewage, making sure that so we don't get this elevated nitrogen and phosphorus causing the eutrophy. That's the root cause why species, especially aquatic meats, are dominating our riverine, our dams, and things like that. And then focusing on the ecosystem as a whole. So moving um, to a holistic view, looking at forage availability, carbon storage, sequestration. And also, I think Llewellyn dwelt quite a bit on it, biodiversity values of our natural resources. So some of the key elements that we need to include is our soil monitoring, vegetation, also air quality. In some cases, understanding air quality, especially in industrial areas, and the vegetation as indicators, as early warning systems uh, in our early detection programs. So the monitoring can trigger. There's certain thresholds when if we cross these, then now it becomes a problem. We can track these things over time and with climate changes, whatever the case might be. If we don't have the monitoring data, we don't understand why such occur in certain areas. Uh, why do they occur there? How do they competitively exclude uh, through interspecific competition or whatever the mechanism might be? our indigenous species, and then understanding the densities. A lot of people do IS studies, and they give you a list of species, and they categorize them according to that. That's great. That's a great start. But how much? What height classes? Is it new invasion, old invasion? We need more information to manage our invasive plant species. So this is monitoring is the tool that enables us to incorporate proactively before these weeks, like Dr. Llewellyn taught us earlier. The tool that we use is a pre-warning trigger, like a warning system for us. We can, in our conservation areas like this one, we can identify common species or those species through various management tools. This is one of the examples that we can use for mapping our indigenous vegetation, which are indicating which are critically endangered, which is vulnerable. There's many different tools. This is just one example. So this is all talking proactively instead of reactively. And also looking at, ecology in detail in terms of the soil, vegetation, the animals we keep. Do we have the right mix? Do we have too many elephants, for example? And also, these species tend to be proliferate or generalist close to water, so they get another effect, you get the biosphere effect. So a lot of bush encroachment close to your water sources because animals continuously the grass layer, and now creates an imbalance in your structure, which now favors your woody on top of the already increasing carbon dioxide levels in the atmosphere. So we want to understand what is these triggers and how do we manage them. And the reason also why, so that we can manage we're the ones that stop the migration routes, the ones that put the fences. Now we need to manage and make sure we have sense of ecological tools in our management system. So whether it be through passive capture, in this case, of Ebola. So what are some of there's many different techniques. I'm not saying one is right and the other is wrong. I'm just giving a few. Like I said, it's be more concerned about trends. What are the key things we need to monitor? Our soil, our water, our air, our vegetation. This is just some examples of indicators of the health of our ecosystems. So it's a method we use called the step point method to a transect, point transect, to find the nearest grass, and that gets classed to a certain category. There's various different methods that we can use. Ecological index, so those are based on, we'll discuss that a little bit later, on key ecological groups, four of them, and then the proportion of each one. Okay, and then other species, other methods, using values, so certain species have more ecological value, so decreases generally, um, for, for higher palatability and acceptability for livestock and for game. Key species, we know which in certain areas, like in our drier sweet fault areas in South Africa, we've identified certain key species that can act as early triggers. If they disappear or start declining, that's an early warning sign that we have ecosystem imbalance. There's a multi-criteria methods, biomass, benchmarking, so we can compare to a pristine area and benchmark according to that. Another method is landscape function analysis. It's quite a nice method because it incorporates both soil and vegetation simultaneously. On the left, it's just an example of a simple, rapid, it's more for fuel load determination, but can also, it's called pasture meter. There's another method called dry weight rank, which on top of just giving you a volume, also gives you the species. So what your decreases, what is the volume of that available for your grazers or mixed feeders. This is just an example of LSA. So you lay a tape out, you measure the size of patches, interpatches. So the patches are your vegetative patches, and the interfaces are your bare areas. So obviously you want more bare areas, then you have better erosion protections. This is just us measuring the width of these patches and describing them in more detail. Do they have surface crusting? Do they have compaction? So there's a set of questions that you answer on that. From our species data, in one of the methods, the ecological index method, we classify them into four groups of grasses. So your decreases, these are your highly palatable, high production grasses with a very good digestibility, albeit for cattle or wildlife. And if we mismanage our felts, albeit through over, under, or selective grazing, these species disappear. They like disturbance, but not too much and not too little. So there's an intermediate zone where they flourish. And they also like fire, but again, not too frequent, not the wrong time of the year. Um, so that all helps us, and it links to our alien invasive invading our veld and our indigenous bush encroaches. Um, so this is an example of one of the decreases. It's the Mira triandra, a red grass, and it's got high palatability. This is increaser one. It's called Hyperineata thatching grass, which they use for roofing mostly. It's got lower digestibility, but when it's young, if you keep it short, it can also, after fire, you can so easily graze this. But when it becomes tall, moribund, high in cellulose, all of that, quality decreases rapidly. Increaser two, this is like Eragospis curvula. These are your species with overutilization, they increase and they dominate your veld. And then you also get what called selective grazes. Now, some people clump them together with increaser one, but there's certain species under selective grazing uh, which can be related to underutilization. These species flourish and are really hard to get the balance back into your veld. Um, so this is an example of a disc posture meter. So you record the height, and then the height gets linked back to your site-specific regression, giving you a biomass. In other words, the volume of grass available for the bulk grazers, selective grazers, and your mixed feeders to use. Um, Another important measurement is basal cover. So looking, and then it relates directly to erosion. There's various methods. You can measure the tough distances, or in this case, using a Levy bridge, recording a hit or a miss of rooted material, because we're not looking at canopy cover here, we're looking at rooted. So canopy cover and basic cover are two totally different things. They are related and have correlations, but two different things totally. Um, Earlier we spoke about, can indigenous species be invaders? Definitely. With bush encroachment, we've seen, especially like you guys highlighted, Tarconanthus and the croton species. Now, if we need to understand why do these species dominate our rangelands, even though they are indigenous. Now there's an imbalance in it. There's too much of one thing, and we need that balance in our structure and in our high classes. So why is the high classes important? Because we need to look at the age of infestation. Is all my invasion in the 0 to 1 meter? That shows me it's a new invasion. It's a disturbance that occurred recently that I need to go and find out why is this now dominating, and then put management actions in place to manage that. Or is it all old invasions, big trees larger than 10 meters? So that distribution of height plot can tell me a lot about what's happening in the veld. And then also another tool that's very useful, it's fixed point photography. And fence line contrast. So on the left, got a farmer using felt and fire correctly. And on the right, but it also depends on your objective. If your objectives breeding kudu, then you'll rather have the picture on the right. If your objective is that having an open system where people can see wildlife, like in ecotourism scenario, and you want that lateral visibility, then you might be on the left. So it's all also dependent on our ethics and our land management and our conservation land use. Some of the soil monitoring chemical, like we spoke earlier, looking at your soil pH, exchangeable acidity, acid saturation. We also look at your macro and micro elements, your macro being nitrogen, phosphorus, potassium, carbon, micro being copper, boron, iron, manganese, those, and also salinity. Physical, we look at infiltration, how quickly, because groundwater is important both from a human perspective and from a wildlife perspective. So we need to understand how does our management impact on our infiltration and our recharge of our groundwater aquifers. Texture, do I have a sandy soil that drains relatively quickly, or do I have a clay soil that holds moisture but might compact? And how do we um, manage such a system? Compaction, this is one of the tools that we use. There's many for compaction. This is the penetrometer. So we actually look at compaction and we measure it at various depths within the soil profile. And then biological, I think for far too long we've ignored this and we don't actually understand. Just like the grass, you need to manage your grass species composition and your structure. We need to actually, if we're serious about our ecosystems, manage our things that are unseen to the naked eye, our soil food webs, our bacteria, our nematodes. Not all nematodes are bad. Some are beneficial. Fungi. We found a fungi that can break down coal into soil. Just by understanding how these things work and that we can actually use them to our benefit. And they're way more sustainable than chemical. Chemical, you just keep topping up. Whereas biological is once you've created the system and it's in equilibrium, like Dr. Llewellyn spoke about earlier, um, the system maintain itself through nutrient cycling, through various, whether it be the water cycle, carbon cycle, all of that. Also understanding our erosion, what is the types of erosion that we get, where are they located, because this is the conditions under which AIS um, they flourish. And how severe is the erosion? And then volumes, what is the volumes of topsoil that are being washed into our dams, into our rivers, and what is the depth that is and width that is being eroded to? Some of the water monitoring, so most of our aquatic alien invasives, the root cause because we've got too much nutrients in our water. So in the case of hyacinth and some of the other species causing eutrophication, if we remove the nitrogen and phosphorus, we indirectly taking away the food source under which these species flourish. So in some cases might be acid mine drainage. So we need to understand our chemical and biological monitoring and have these early warning trigger systems based on thresholds of potential concern. I think Dr. Llewellyn, you guys at Kruger Park have really done and are the leaders in this threshold. So they can definitely learn from you of that. This is just some of the example of the data that we get without going into too much detail. So we get the list of how much you can see in out of 100 points, we only got one decreaser in this entire site. Increase to one, those are your underutilized, 24 in total. So you can see this site immediately shows you just by looking at this piece, overgrazed, overutilized, not rest, where grass plants don't get time to produce seed because they continuously graze, like in the communal area. They never get time to set seed, especially during summer, which is the key seed vigor restoration and restoring your root reserves. So if our roots are healthy and we're feeding our soil, our plants are going to be healthy and then in the right balance. So this is just some of the tools that we use. So one of the so it's hard for people to understand the different classes of grasses. So we've developed a method just visually how over time is the proportion of those decreases, increases, forbs, and over successional time, how do they change according to certain management utilizations? So on the left, we have our climax vegetation. So that's where your benchmark will typically be, where you have a 1. And then your we have the 2 and 3. Those will be now you're going along the degradation. 2 will be where your increase. So 1's dominate, so your felt is underutilized, and 3 will be where your increase is 2 and your forbs dominates because your felt is not rested. So those are the conditions that trigger bush encroachment, alien invasive. So, and we can pick them up early if we look at these things and looking at the proportions of these things. And it can show us how does our felt or our soil respond to various management interventions. And if our system is not working, we can, through adaptive management, measure and then change our management systems. Someone in the earlier section asked about the indigenous species becoming invasive, definitely from a bush encroachment. So the way we manage that is through bush density surveys. We use various methods. The purpose of it, again, we look at height classes because we want to understand, is this a new invasion, old invasion, or a mixed? Also from an ecotourism, you guys want to make money from your land use. So your people are paying pounds, dollars to visit your areas, and they don't just want to come see a bush encroached areas. They want to see the big 5 or the tiny 10 or whatever the case might be. And you want to give them that lateral visibility. Uh, and we convert this information into tree equivalents and ultimately into browsing units to get a browsing. This is one of the nature reserves, Sabi Sands. We will currently have a program. So this was how it looked before bush thinning, before bush encroachment control, understanding the drivers and causes of bush encroachment. And this is after the same area. You can see the lateral visibility significantly better. People get a whole lot better chance of seeing what they came long distances to see. And the structure of your grass versus bush ratios, we can fix those and use the early warning systems and thresholds. So this is just more detail on determining the amount. So we split the ecological available forage, be it grass and browse, into different categories. Bulk grazers, those are like buffalo, rhino, hippo, mainly non-selective. This will have a certain degree of selectivity, but a whole lot less than a blessed buck, as an example. And the mixed feeders, they have the ability, that's why they're so successful, like the elephants, impala, they can move between grass and browse. And then our browsers. And then we look at the proportions of this in our pelts to see, is it overgrazed? Am I overutilizing my tree layer or my grass layer or both? And in this case, you can see on the left, at the bottom left, this is within your grazing units. You can see the bulk grazes are way overstocked by 77% on this particular property. And the selective grazers, now those ones are the ones that stay in one patch for a long time, highly selective, small mouths, so they can select very carefully, um, and they also tend to congregate around water, making the problem even worse. And you get this biosphere effect, with the impact close to water being way more severe than further away from water. So we also need to have the right balance of water on our property. And on the right, we look at the browsing components within the vegetation and making sure we don't overstock that portion of the reserve. And then in terms of alien invasive plants specifically, what are some of the key things we need to include? So locations, obviously, where do they occur? And using fixed point photography, taking a time series of photo at the same place, at the same height. It's also a very useful tool. Some of our legislative requirements, these weeds have been classified and categorized. Cora is different to Nimba in our case, in Southern African example, and we've got our own categorization, so that overrides. Overrides the density argument. And then we classify according to density. So how much per hectare? No use telling me you've got Datura. Where are they? How many? How high? Where are they? Are your interventions working or not? And if not, why not? And let's understand, is it a new invasion, old invasion? Uh, for the woody species, your bush encroachers and black wattle, like I think Kirsten spoke about that, Acacia Menziei, we need more information about how thick for the contractor that's actually removing them, albeit community that you've trained them. They need information about the stem diameter. Is it narrow stuff that I can use a brush cutter, or do I need a chainsaw? Um, and then we also need to monitor not just for woodies, but also for herbaceous. Are they for woodies coppicing, and for herbaceous, do we have new species coming along? And then this is just an example. So you can see within the various species, totally different high classes dynamics. So black wattle, you can see a whole range of small indicating new invasion. Okay, and that we can easily, and also we can use fire, can easily get, if the fuel load's available, to get a top kill. We can easily use fire, or in some cases, under control grazing with goats and cattle, you can also use these wattle. If you look, just make sure you look at the tannins and the crude protein, because you don't want to move from a crude protein content in your grass of 3% to 15% in wattle overnight. You want to do it gradually, but we can assist with that. And then, for example, you can see in your poplar a whole different dynamic. This is the old invasion. It's trees in the 5 to 10. So there are some smaller ones, but the majority is in the old. So there's something triggering new invasion, but there's also a population of old poplars in this case. So what we do, we generate, this is your total across all species density maps. So that goes back to my earlier, a lot of people go straight to the red area because it's the easiest to see, a lot of them, but then end up not, what about the rest of the property? And end up not doing the follow-up and maintenance monitoring. Um, so what we propose, rather go for unless it's there's legal requirements. For example, in South Africa, category 1B under NEMBA, you don't have a choice whether it's high density or low. You unfortunately have to control it, and you have to have an integrated species management plan specifically for each of those species. But if not, target your light density areas first. In other words, your blue areas. Once you've finished with the blue, move on to the green. Once you've finished with the green, move on to the yellow, and then only get to your red, unless, like I said earlier, it's close to an area of conservation importance or required by law to protect to remove or control those species. This is within a species, so same property. You can see this is total AIS densities. And I can see black wattle, it differs. So you can't have the same management strategy. So we make it species specific. because our herbicides, I think David will talk about that a little bit later on. Our herbicides are species specific. So each species has its own unique herbicide that's specific for that species. So here we can see a black wattle. It's not just like all the others in this, but so I hope it's not as dense across many areas. So this is a quick gain, and we can focus our efforts on the blue areas first, move to the green, etc., etc. Then we go into further detail. We split it into high classes. For example, if you want to release your seed weevil, which is your biological control for black wattle, no use releasing it in the 0 to 1 meter high class because those trees haven't even produced seed. What's it going to feed on? You want to release it in the higher than at least 3 meters high class. So we can tell you exactly for your biological control, which requires the seed to predate on to prevent the spread. We can tell you where's the optimal area to release it. In this case, will be the red zone there, high density of tall trees. So we can, because we've got the monitoring data. If we didn't have the monitoring data, it will be a guess. Now we're basing it on science. How do you prioritize? How do you choose? Which areas do I do first? Which areas do I do last? Um, so first of all, level, like it or not, it's legal compliance. That's non-negotiable. That applies to all landowners across all land uses. You can't override this level. It will always be your priority one. Okay. For us, what the second level, but you can change this. That's why we usually workshop this with the landowners, with the communities. You can prioritize rare habitats. For example, in this case, we said wetlands, our pans, like you can see here, we prioritize that. And our drainage, our riparian zones, we prioritize that as a priority one. Then within that, we further split it. So within that priority one area, so you can see we'll start in our blue area first because that's the light. There's maximum 579, and we actually counted them species maximum in the blue region. So we're going to clear this area quick. We put a time to it. We're going to do it by September, not in the winter. You can see none of these months are in the winter because the herbicide doesn't work as effectively in the winter. It might work late autumn, and we've got some interesting results on that. In some cases, it might work in late autumn. Then once you finish your blue area, you move to your green area, etc., etc. So it's based on science, based on densities, and then you can add. We've in some cases added additional prioritization and risk ranking. We've said some people are busy with rehabilitation, so they see a topsoil stockpile as a priority area. Other cases, it might be for communal value or ecosystem services value. People use it for firewood. There are some risks with that because they might not cut it low enough for the herbicide to reach the roots. But if we monitor, again, we can manage it. Without monitoring, we can never manage it. They might use it for charcoal, flood attenuation. A lot of our communal areas are built inside the flood zone, 1 in 100 year flood zone. Some cases even the 1 in 50 year. Or we can prioritize erosion control as a ecosystem services value. So this is in some cases where we have extreme invasions, we might require some rehabilitation or restoration. They're not the same thing. They're two totally different things with totally different objectives. Restoration, that's what you'll normally do in a wildlife scenario. Your focus is on biodiversity and resilience. While rehabilitation, this will be more your communal areas where you want a lot of grazing, so high biomass of grazing. So it's more focused on the human use but it doesn't have not any, very limited biodiversity. It has low resilience and low sustainability. It continuously requires inputs, fertilizer, um, et cetera, to maintain those levels of productivity. So they two very both useful in their own unique circumstances. And this is an example. Native species. These species are not usually commercially available, and they have a narrow window where the seed is actually ripe for you to harvest the seed. But we can through planning, we can determine that window when the seed is actually ripe. Harvest the seed. This is just one of the methods. Harvest the seeds while it's ripe. Plant it with. So generally, people will say no, native seeding doesn't work. Firstly, because they haven't broken the dormancy. Second of all, they harvested the seed when it wasn't right. And thirdly of all, they if you broadcast it, what's going to happen? Your large seeds are going to fall first, then your medium, and then your small. We don't want that. We want a mixture. So we've developed some where we can. It's actually a gel that we suspend it in so that you have your large, medium, and small within the same zone. You don't get patches of large, small, and medium. They're all integrated, and there you can see us on mined land establishing. I think we established on pasture. Usually, at best, you get the most I've ever seen is 15 species. We established 40 species, excluding forbs and your herbaceous is plants. So it is possible, even for the forbs. It is definitely possible. You just have to understand the ecology and manage it. But it requires planning in advance. Rehabilitation on the other hand, a whole lot easier. Can do it on a large scale. Things are commercially available. We can do this with our eyes closed. So yeah, that's that in a nutshell. So the conclusions, we want to move our alien invasive management from being reactive to being proactive based on the principles of adaptive management, where we learn from our successes and our mistakes, and we put things in place to make sure that we build a resilient ecosystem that can resist um, these alien invasive and indigenous encroachers. Um, through various processes. And the thing that enables this, without this middle piece, we can never do this. Without monitoring and evaluation, and we've discussed the differences between them, this will not work. And then we need to integrate this in all phases, not just in the initial control, in the follow-up, in the maintenance, in the monitoring. And it needs to be focused both addressing the root causes and the symptoms simultaneously. So I'm not saying herbicide doesn't have a role. Of course it does. And without it, we'll never win this battle. And the same with biological. But we need to do this simultaneously and preventing new infestations and bush encroachments for the indigenous stuff and continuously monitor, maintain, and through adaptive management, get our felt rehabilitated or restored. True restoration is really hard, but we can, at least to some degree, restore some of the functionalities, some of the structural integrity. So, how do we do this? We do it through all the phases. We prioritize correctly based on legal, all those different processes that we've discussed. We make sure that we don't just address the symptoms. We address both soil, water, even air quality, and felt simultaneously. And we have long-term monitoring. We don't stop as soon as we see a little bit of success. Like Dr. Llewellyn showed us, they've got long-term and they can clearly see the cycles. Now they understand how the biological control works. But if they didn't have the monitoring data, there's no ways they could understand how the biological control works. And then in severe cases, unfortunately, in those dense areas where we've now removed the vegetation, we will require some form of rehabilitation or restoration to prevent soil erosion and conditions where these species can reinvade at even higher densities. Thank you.
Thank you, Gustav. Wow, I've learned a lot from you. Thank you so much. I really enjoy and value your holistic ecosystem centered view and the adaptive management approach that you take. Yeah, how many land managers actually bring the soil into the equation and all its life? So yeah, thank you so much for this contribution to our discussion today. Um, you were talking a lot about how important long-term management and monitoring is. And from what I understand, this is not always happening, and it's very difficult to convince funders and landowners to continue supporting monitoring and follow-up management. So, what would your advice be to convince those funders and landowners to continue? How would you do it?
Okay, that's an easy one. Use Dr. Llewellyn's data to show them, for example, the prickly pear. How did we, through monitoring, understand the population ecology? So I didn't have the data like Dr. Llewellyn in Kruger National Park has, and it's relatively low cost compared to chemical. And so a lot of times, I think our problem as environmental managers, we often talk, and I'm very guilty of that myself as well. We talk in ecological terms. We don't talk risks and money. People, managers of reserves are not necessarily ecologists. They might be financial managers, they might be CEOs, the decision makers. But if I can speak their language with the understanding, ecological understanding in the background, I say the same thing, but I just say it in a way that they understand, which is rands and cents to business. So I think often we've got good intentions, but just the way that we come across doesn't make sense to an engineer, to a CEO. So it's the way we sell what we want them to do. So we just need to change, if I can call it, our vocabulary, the way we and just speak their language in a way that they understand it. So that will be um, my view on that. And then just showing them, because once managers understand these systems, we, myself and LD, was also on the other discussion with some land managers last week. Once they understand, why do I need to not overstock my land? And then show them how these things are linked. Then they start, they actually start owning the thing. They get excited about soil erosion control, bush encroachment control, because now they understand it. And if you can put an economic value to it, so let's say, for example, he has sable, and now by you controlling your bush encroachment, you can have him without overstocking the property, obviously, between the ecological carrying capacity. You can increase his density of value. Now you're going to have his airtime, and he's going to listen to everything you say when you talk sense, which is supporting his business. So achieving the same thing, he's just saying it different. I don't know if that answers the question.
Yes, absolutely, Gustav. Thank you. Very good answer. I think that it's true for so much of science, how it gets interpreted to people that are not academics, and how effectively it can then be applied and implemented. So yeah, thank you very much for that. Yeah, it's just actually a note to my colleague Johan. Gustav, thank you for mentioning that the black wattles need to be 3 meters high before they can be controlled with biocontrol. Yeah, it's just interesting to know when that biocontrol agent needs to be released, and that obviously comes through your research. So yeah,
Yes.
we are having a very high density of Port Jackson in our area, and I'm sure the same is true.
And I haven't worked extensively on that, but Dr. Harding and his son, they'll be able to definitely guide you more on that. I know yeah, Dr. Harding has done extensive work on that. So the same principles apply, but I just think they've got more species specific. So Graham and his son will definitely be able to assist you. And then I think Llewellyn would also, from a biological control perspective, so be able to assist you there as well.
Fantastic. Thanks, Gustav. There's a question that came in from a Wildlife Tourism College student, Ladama Soyet. And I'm going to ask you, Gustav, and then David, who's up next. You can see his camera is on. David can continue the answer if he has anything further to add. So the question was, can these plants, and I think they were referring to Opuntia, but I'm not entirely sure what the conversation was at that time. Can these plants become resistant to herbicides, and how can this be prevented? Gustav, do
Yes.
you want to go
So,
ahead?
yes, I'll try, and then David can just add as well if he's okay with that. So, like, there's a whole range of mode of mechanism how these herbicides work. So it's like me. Let's say, for example, I get TB and I don't finish my TB medication or I don't use it as prescribed, even though it is curable, because I'm not using the medicine, or in our case, in plant management, the herbicide correctly. Now it builds resistance, or I'm not using a wetter with it or a surfactant, making the herbicide stick to the plant. So, in other words, I'm not applying the herbicide at the right concentration. I'm not calibrating my equipment, etc., etc. And by me not following the label and not calibrating, in, um, and in some cases applying too much can also be create problems. So, um, and using the same herbicide year after year, that can also build up resistance. You need to move between these like four groups of, but I think Dr. Harding or David can elaborate further on that.
Thanks, Gustav. David,
Yeah,
would you like
yes.
to jump in?
Sorry, when the question was asked, I actually changed my presentation a bit. I've added two more slides to
Well
just clarify
done.
it with some pictures because unfortunately, herbicide resistance is probably the most misunderstood and misrepresented topic in herbicide. So I think I'm not going to answer it now. I'm rather going to go through my presentation and go through some other herbicide basics, which will give a little bit more knowledge or insight for people who don't have herbicide experience, and then move on to the topic of resistance. But it is going to be covered with a little picture in my presentation.
Perfect. Thank you so much,
Thanks for
David.
saving me.
I've got a last little comment here from one of my colleagues. It says, it looks like an invasive plant is always a sign of too much or too many of something in the ecosystem. And I'd like to add to that maybe also too little. But Gustav, what is your sense on that?
100% spot on. There's actually a theory called intermediate disturbance hypothesis. Like I say, too much fire, plants don't like it. Or your too little fire, like if you exclude fire from paintballs, as an example, we've seen in the Western Cape, those areas, and then we end up getting too intense fires. Now we change the whole fire ecology. So this is a spot on comment. We need to find that intermediate zone of disturbance. So plants do like disturbance, but at the right time. So, if, for example, if you burn at the wrong time, and or if you don't follow up, like wattle, for example, you'll get mass stimulation of the seedlings, which is great. Then now, if you apply what David's going to speak about, the herbicides, you can club them on. But if you miss it, now you're creating a now you've made the invasion worse. So we just need to understand what is that intermediate range. So I don't want to overstock and I don't want to understock. And I don't want to overburn or burn at the wrong time of the year or not burn at all. So we need to find that, like I think Dr. Llewellyn spoke about that equilibrium in the ecosystem. So a very good observation, and yeah, no, it's pretty good. I can send more information just for interesting sake about the intermediate disturbance hypothesis.
Thanks, Gustav.